what is VLAN, or what do you understand by VLAN in your own words? The question I asked is, what is VLAN? What do you understand by the word VLAN? What comes in your mind? Explain VLAN in your own words.
Yes. Can you hear me?
Yes, I do. Yes, go ahead.
So VLAN is a group of user. I mean, it's a way of grouping users together, and it's part of the single broadcast. And if there are users on the VLAN on the same stage, they can talk to each other. That's all.
Okay, so VLAN is a group of ports under single broadcast domain. VLAN groups devices as one group. Members of the same VLAN belong to one group. Members of same VLAN can communicate each other. Wonderful. That's nice answer. Anything you want to add, Mr. Sheikh?
No, sir. VLAN is virtual LAN, sir. You want physically switch is converted to the logical switch used to the VLAN.
Nice. One physical switch with multiple virtual switches. If no VLAN, then we need to buy multiple physical switch in order to isolate traffics from one group from the other group, from one group to other, which is costly. By creating VLAN, we isolate traffic between VLANs, VLAN members, without buying a new switch. So VLAN is logical separation, or VLAN is creating virtual switch inside the physical switch. Good answer. Any other answer?
So 496.
Very good.
The
Bravo, bravo. The maximum number of VLAN that we can create is 4096. But not every switch will support this 4096. Some switches will support up to 1005. Actually, they are all controlled by softwares. Just to make money, the vendors do that. High-end switches, the software allows you to create up to 4096. Low-end switches, because it is cheaper, they don't want you to create multiple VLANs. They limit it to 1005 VLANs. The reason they will give us, say, it's a low-end switch, you don't have many ports, you cannot send much traffic, there is no need for you to create more than this number of VLANs. So giving this 1005 itself is too much for the switch. That's how they will talk. Anyhow, according to the industry standard, the maximum number of VLAN that we can have on a switch is only 4096. Not possible to have more than that. Okay, next. This is a nice question and you answered almost everything. VLANs break down the default broadcast domain, one large broadcast domain that we have on a switch, where all the ports are members of the same broadcast domain, which is also called as VLAN 1. By creating VLANs, we break down the broadcast domain into multiple broadcast domains. What is the advantage? Advantage is management, easy management. If any link failure or if anything happens in VLAN 10, it won't affect the members of VLAN 20. So the impact is localized within the VLAN member. Not every port on the switch is going to experience the impact. Only those ports that are member of that VLAN will have the impact. For example, if one of the VLAN, let's say VLAN 10 member send a broadcast, that broadcast will consume the bandwidth of those ports that are in same VLAN, not sent to any other VLAN member ports. In this way, VLANs improve the bandwidth. When I read this point like 17 years before, VLAN improves bandwidth, I was like, hey, these guys are talking too much. They simply want to boast things. How can a VLAN improve bandwidth? Only when you increase the cable's capacity, when you buy some bigger, better quality cable, standard cable, bandwidth will be included. How can VLAN improve the bandwidth? Later, I realized that yes, VLANs improve bandwidth. If you don't have VLANs, all will be in same broadcast domain. Broadcast sent on one port is going to impact all the ports. But when you have multiple groups under different VLAN numbers, the broadcast happening in one port of a VLAN will impact only the members of those VLAN, so of the same VLAN, those ports of the same VLAN, not any other ports. So other ports are not experiencing unnecessary traffic flooding. As a result, the bandwidth is improved. Their bandwidths are not unnecessarily consumed. So performance gets improved when you don't waste bandwidth, when you don't unnecessarily waste processor. The TCAMs, the ASIC, the ASIC chip, they don't get unnecessarily the packets to process. So definitely the performance gets improved, bandwidth gets improved, isolation of traffic from one VLAN to another increases the security, and all these advantages we get through VLAN. Wonderful. Let's go to the next question. What do we understand by the word IVR? That V stands for VLAN.
Inter-VLAN routing.
Exactly. Inter-VLAN routing. What is inter-VLAN routing?
Because since the hosts within the same VLAN cannot talk to each other at layer 2, so you basically use some sort of a router to provide routing between the two subnets of VLAN.
Exactly. Inter-VLAN routing is routing between two different broadcast domain. How do you define broadcast domain? VLAN is a broadcast domain. Members of same VLAN or in single broadcast domain. So when someone wants to talk from one broadcast domain to another broadcast domain, in another word, one network to another network, because each broadcast domain will be in different network. So when each VLAN have got different network, communicating between different network is only possible through router, a layer 3 device. In another technical term, if you need to say, inter-VLAN routing is routing packets between different broadcast domain, different VLAN, different subnets. So it involves a layer 3 device. Only a layer 3 device have got broadcast domain on each port. Each port, it can be a physical port or a sub interface like F0/0.1, 0/0.2. One. So each, this is a physical interface, these are all sub interface. Each interface on a router is a member of different broadcast domain. And router helps to connect between broadcast domain, distribute the traffic between broadcast domains. So inter-VLAN routing is nothing but routing packet between members of different broadcast domain, different VLAN. And this can be done on a router. It can also be done on a layer 3 multi-layer switch, which has got a limited support for layer 3. See, multi-layer switches support layer 3 and layer 2, but not full-fledged layer 3 switch. It's a switch with limited layer 3 support. That's inter-VLAN routing. So if you are doing inter-VLAN routing, what all need to be considered? Let's see, doing inter-VLAN routing on a router, which we call as a router on a stick. This is a well-known story. I know very well you have gone through this before. Just as a reminder, when you do router on a stick, you have a layer 2 switch and you got a router. And you may have 4 or 5 or 10 VLANs, or more also you may have. So when we have multiple VLANs, I'm just taking for example 3 VLANs. Blue VLAN, red VLAN, and green VLAN. Now each VLAN is a different broadcast domain, so I need to have 3 connections because each port is one broadcast domain. I need 3 connections, and the subnet of blue, let's say subnet of blue is 10, subnet of red is 20, subnet of green is 30. I'll give an IP address 30.0.0.254, 20.0.0.254, and 10.0.0.254. So that the inter-VLAN routing will happen. But what if I have many VLANs? When we have many VLANs, for each VLAN providing a physical link is not possible. So in that case, what we do is we create sub-interface. Physically, we will have only one link. But we create sub-interfaces so that for blue one link, for green another link, and for red another link. It's actually one port. We subdivide into multiple ports, which means routers are ready to do routing between these three networks, even if they come inside the router via single physical port. Routers are ready to differentiate them according to the color. Here color is VLAN ID. So router is ready to support .1q. That is why when you configure subinterface, you need to say all the traffic that is coming from the switch with the VLAN green, let's say 30. For green, let's give VLAN number 30. All the traffic that is coming on this shared link with VLAN 20 is another broadcast domain. All the traffic that is coming with VLAN 10 marking is another broadcast domain. So now when the router when the switch send the packet out, it needs to tag and send, for which I need to configure this port, the black port, as a trunk port. Only then the VLAN IDs will be attached while sending the packet out. And when the packet goes to the router with the VLAN ID 30, it receives the packet under this virtual interface, even though the physical port is same. And based on the destination, it will decide whether to send it via the blue or the red. So the constraint is you need to have a trunk, only then you can map with a VLAN ID and send the traffic out, so that the VLAN ID can be matched against the subinterface VLAN encapsulation that we configure when you configure the encapsulation type under the subinterface. Yeah, that is how we configure subinterface. When you configure subinterface, when you create a subinterface, well, you need to provide the VLAN to be encapsulated, or the VLAN that will be encapsulated on the packet received on the subinterface. That's how the command goes. Encapsulation .1q VLAN 10, VLAN 20, VLAN 30. On the switch, we don't create any subinterface. We just use the physical interface. We make it as a trunk. That's all you need to do. And all these ports are access ports. Now there is again another two ways the inter-VLAN routing can be done, but the other two are using multi-layer switch. In a multi-layer switch, you don't need to do this many hard work. Just one switch where we have some VLAN members, ten, 20, and 30. 10, 20, and 30. Yeah. So routing between these VLANs, they need a layer 3 interface, for which we create a virtual interface called SVI, switched virtual interface SVI. For VLAN 10, one SVI, for VLAN 20, another SVI, for VLAN 30, another SVI. And that interface is a common interface for all these VLAN members. We create a virtual interface which will be common for all the VLAN member that matches the SVI ID. If I have interface VLAN 30 and this 30 access ports will use that interface VLAN 30, and the IP address on the interface VLAN 30 will act as a gateway for all this VLAN 30 members. Likewise, IP address on the VLAN 20 will be acting as the gateway for all VLAN 20 members, and likewise on VLAN 10. So this is another inter-VLAN routing. There is also one more where you may have a routed port on the switch, meaning you go to the port and say no switch port, and each will be a member of different network. Let's say this is a 20 network, this is 13 network. Here I may have 10 network on one interface, 40 network on another interface. It's a layer 3 interface. So even now the traffic can go from 30 VLAN members to 50 interface, which is in one LAN. This is one LAN, and this is another LAN. And this is acting as a distribution layer switch because you got an IP address right on the physical port itself. You say no switch port to make it as a routed port. Yeah. So when we say inter-VLAN routing, all these are inter-VLAN routing. Do you have any question on this inter-VLAN routing? Is it necessary, or do you really want any lab to be done on this topic of VLAN and this IVR?
I'm clear on it, so I don't.
You're comfortable, right? Next. We have an attack called MAC flooding attack. To prevent the MAC flooding attack, we use port security. We all know that. Like port security, we have a lot of other security mechanism through which you can mitigate attacks based on VLAN hopping, attack based on BPDU, based on CDP. A lot of things are there. Loop avoidance method like loop guard, BPDU guard, loop guard, UDLD, and so on. Or sometime, we'll have a spoofing attack. ARP inspection will be the best option to avoid the ARP spoofing, dynamic ARP inspection, for which we use DHCP snooping table. So in all this, when there is some violation, whether it's a port security or DHCP snooping or BPDU guard or root guard or dynamic ARP inspection. In all these cases, when there is a violation happen, when a violation is identified, the port will go to inconsistency state. To recover the port from the inconsistency state, what we do is we do manually shut down once on those ports that are under inconsistency state and bring it up by typing no shutdown. Do you know any mechanism where it can be automated, where you no need to manually enter shutdown and no shutdown? This is the question. When a violation happen, when a violation happen, the port goes to inconsistency state. But to recover back, you need to manually go inside the port, shut down and unshut, no shut. But this can also be automated. Do you know any way that it can be recovered back automatically?
I remember there is either a command or some EM script to do that. I mean, you can have an EM script to do that, or there may be a command which automatically enables the support back after some hours of it being disabled.
That's right. We call it as error disable recovery. You need to go under error disable recovery and say what violation. Is it violation on BPDU code or port security or any other? You need to mention the cause for violation. Cause why the violation happened. Okay, if happened, what should I do? If violation happened in port security, then I need to choose that option under the error disable recovery and say in future, if violation happens and port goes to inconsistency state in port security, then the interface should come up maybe in 10 seconds. Automatically it will come in 10 seconds, whatever the time you mentioned. When you enable error disable recovery, the default timer is 300 seconds, which is 5 minutes. But you can increase or decrease the number of seconds. Right, support security is not only the feature that can use that auto recovery. Any feature can be DHCP snooping, it can be DHCP, SIRP inspection, anything that will put the port under inconsistency state during the violation can be automatically recovered by using a feature called error disable recovery. Error disable recovery. Right. Next is about STP. About STP, what makes STP to find that there's going to be a loop? How STP can detect or find the possibility of loop? What makes STP to detect the possibility of loop?
If it's getting the BPU of its own, like
BPD. Wonderful. When it receives its own BPDU via other interface than in which it's sent, that makes the STP to be in an alert mode. That makes STP to identify there is chance of loop. That's very well said. That's right. How often these BPDUs are sent on the port? Will it be sent on all ports or will it be sent only on the trunk ports? How often BPDs are sent? And will it be sent via all ports or only it will be sent via trunk ports?
Trunk port, sir.
Any other answer?
I think all ports.
Right. BPDs are sent via all ports, including access port. So, there is no constraint in that. It will be sent via all ports, not only via trunk port. All right. Now, next is how often it is sent? Every 2 seconds. Every 2 seconds. The wait time is 15 seconds. After that, the 20th second it will take decision. Spanning tree avoids loop by blocking ports. Actually, blocking a port is wastage of resource, but there's no other option. In Ethernet world, there is no other option. There is an option even in Ethernet world. We have VSS, a concept called VSS, in which you will not have STP. You can use multiple redundant paths. In Nexus world, you can totally avoid STP because STP is wasting our resource. Right, so I think there is no need for us to talk much about VLANs because you are very good in that, and also inter-VLAN routing. So we are going to get into this error disabled recovery lab, and then we'll get into STPs. STPs will take just one day to finish all STPs because we have gone through STPs in CCNA and NP. So we'll finish once for all the STP types and error disabled recovery in our next class.